Hello and welcome to the SAT 123 prep program. Today we're going to be going over a pretty large topic. It's problem solving and data analysis. It makes up 29% of all your points on the SAT math section. So it's kind of 17 questions, I believe. So it's a pretty big topic and it's going to take a pretty long video. So we have kind of a checklist of everything that this video is going to go over. It's going to be somewhere here, right? So there should be around 7 topics, right? And we're going to go through every single one. And if you're able to understand every single one of these topics, you should be set for this topic, right? Oh, I keep saying topics, but you get the idea.
So the first subtopic that we're going to go over is knowing how to use ratios, rates, and proportional relationships, right? So I'm going to give you a little animations to kind of help conceptualize what this really is. So imagine you're on a farm, right? And you have a lot of fences, right? And all of these fences are 4 feet, right? And if you actually measure it, right, you see that at 6 o'clock, the fence is 4 foot and the shadow is 6 foot. So from that, you can tell that the fence is 2/3 the length of the shadow. So from here, you can kind of write a proportion, right? And there really are 3 ways to write a proportion, right? So there's the fraction form, right? So in this case, let's just say 3/2, right? Let's say this is the ratio of a shadow's length to the height of the object, right? Or we could say 3/2, or we can say 3. Let me write that better. 3/2, right? So these are 3 different ways, right? The way that we were able to get this 3/2, right, is that we knew that the length of the shadow, right, was 6 foot, right, and we knew that the height of the fence was 4 foot, right. So then this just, let's say 6/4, and this simplifies down to 3/2, right? So now we know this relationship, right? And a tip that I strongly advise you use is always label it, right? Or at least mentally know what this is. This is measuring shadow length, right? And this right here is measuring the object height. So this is very important because whenever you write a proportion, right, you have to know what goes on the top and what goes on the bottom. Because let's give another example, right? So let's say now we have this pole, right? So this is the fence, right here, and we know that it was 6 foot, right? 4 foot, and its shadow was 6 foot, right? So let's draw that really quick, right? And now let's say that we have this pole, right? So we have no clue how tall this pole is, right? So this is a giant pole, right? And I can't even draw the shadow of this, right? So let's say that we know that the shadow's length, right, is 15 feet, right? But we have no clue, right, what the height is. So this would be an x, right? Because we can't, yeah. So how would we use at 6 o'clock? Remember, this is all at 6:00, and let's say p.m., right? I don't know if this is realistic, but all right. We know that when you have the shadow's length, right, over the object length, it's always going to be this ratio, 3/2. That's the relationship between an object and the shadow, right? An object and the shadow. We don't know the object height, but we do know the shadow length. So this is going to be 15, and our denominator is going to be the x value, right? So what we do from here is that we cross multiply, right, in order to get the simple equation that we can solve. 3x is equal to 30. We divide by 3, and you get that x, the height of this pole, is equal to 10. And this is kind of how you can find the height of things without even having to literally measure it. You can just measure the ground, right? So this is kind of a way to conceptualize ratios, I guess. They're just relationships between 2 numbers that you can use in different situations to find out what you don't know, in this situation, the height. Now that we're done with that subtopic, let's move into another one. Understanding the difference between simple interest, compound interest, and linear growth. Every month, Jamal adds 2 new books to his library. Which of the following types of functions best models the number of books in Jamal's library as a function of time, right? So first, from this, you know that they're asking for y, right? So let's say that y is equal to the number of books. So the first thing you always want to do is set your variables, right? So they're asking you to kind of find out what type of function it would be. So let's create one. And x is equal to a month, right? So number of months, right? So here he says every month Jamal adds 2 new books, right? So the number of books, right, is equal to 2 times the number of months that have passed, right? Because every single month he adds a new book, and this is assuming that he has no books to start with, right? So obviously, if you see this, right, a quick, easy way to determine whether it's linear or exponential is by determining if x is a coefficient or if x is an exponent, right? If x is an exponent, it's exponential, and here it's not, so we know that it's not c or d, right? So now we have to determine if it's increasing or decreasing, and for that we simply just look at the sign of this. If this was negative, it would be decreasing. If it's positive, it would be increasing, so that you know the answer is A, right? But what I kind of want to go into the behaviors of each of these lines, right? So if we have an increasing linear, right, and I were to draw this, right, this is kind of how it would look, right? It's straight, it's going, and there's no curves, no nothing like that, right? And a decreasing linear, right, would be the same thing, but in order for this to be a decreasing linear, right, the way that we would have to change this problem is that he would have to start off with a certain amount, and every single month he would lose, right? So this is increasing linear, this is decreasing linear, right? And a way to kind of spot exponential functions when you're looking at a graph, right? So let me draw an increasing exponential function, right? Is that when you draw it, you're gonna start at some point, right? And it's gonna start out all right, going at increasing slowly, and it's gonna increase more and more and more and more, right? So in order for us to say to create an exponential a situation in which Jamal's books would like be exponential is that, let's say they had to buy it, right? He has his books, right? And one of these books, oh man, that's so bad. Okay, so let's say that he had to buy a book, right? And one of these books is $300, right? So 300, right? This looks like a brick, but whatever. So $300, right? So we can now create a function of how much he owes, right? So 300 times some number, right? So we know that, let's say that he didn't have $300, right? And he because he loans it, right? There's a 1.1 interest every month, right? So now this is going to be multiplied by 1.1 to the power of how many months pass, right? And this is because after every single month, right? Month 1, he's going to get multiplied by 1.1, and then month 2, he's going to get multiplied, his original amount is going to get multiplied by 1.1 over and over and over again, right? And what happens is that when you deal with exponents, right, numbers get larger and larger and larger and larger, because if you do 2 times 2, right, you get 4, and then you do 2, and then you get 8, and then you do 2 times 2, and you get 16, and you see here, you at first you only increased by 2, right, but then you increased by 4, and then you increased by 8, right? So you're always increasing more and more and more, and that's results in this, right? So now let's finally go into the decreasing exponential, right? So let's draw the graph right over here, and let's connect these two. So this goes from here to here, and this is going to go from here to here. Sorry for the mess, by the way. So now let's just draw this, and this, once again, let's say that he bought the books, right? And the value of these books are depreciating, right? So when you're dealing with exponential functions, you have to know that in order to know whether it's increasing or decreasing, you have to look at this number right here, the thing that's multiplying your original value. If this number is greater than 0, then it's going up. If it's less than 0, then the value is depreciating, or it's decreasing, right? So if this value is above 0, it's an increasing exponential. If this value is below 0, it's a decreasing, right? So this, contrary to this, it actually falls a lot, right? The value kind of falls, but as you go along, it starts decreasing less and less, right? And that's because, let's say that you do 0.25, right? And let's say that every month his book goes 300, is 1/4 of its, or 3/4 of its original value, right? So when you do 0.25, and if you multiply it by 0.25, let's do it in fractions, you get 1/4, and then times 1/2, you get 1/6, and then because of how fractions work, you're actually decreasing less and less every single time, right? So now you know how to differentiate between increasing, decreasing exponentials, between linear and exponential functions and increasing and decreasing linear functions. So I hope that helped. Alright, so this is another example problem that I want to go over. If you haven't done it, just try to do it on your own and see if you can. So the table above gives the initial number at time equals 0 of bacteria placed in a growth medium, and the number of bacteria in the growth medium each hour for 3 hours, right? So we know that it's in here for 3 hours, and that is growing, right? But which of the following functions best models the number of bacteria, n of t, after t hours, right? So it's basically asking which function best models the growth over these 3 hours, right? So the first thing that you want to do, right, is kind of just have a gauge of how much the growth is, right? What's the change? Is it constant? Is it not, you know? So right here, I can already kind of tell that this is an exponential function, because right here you kind of have exponential behavior. 4 times 4 is 16. 16 times 4 is 64, right? And we can see that 4, 16, 64. So I already know this is going to be exponential based on the here, right? And I also know that because the difference between each kind of hour is not the same. So we know that these are linear functions, right? Based off of what we said before. So these two you already know are wrong, right? Then we go into C and D, right? And as we said before, right, an exponential function is when you have something multiplying by a number that is to the power of a variable, right? But here you can see that you kind of have two, right? So which do you pick, right? So this is something that the SAT also tries to kind of include to trip you up, right? So this, when you see this, right, this is actually means whenever you see 4 to the negative anything, right, this is equivalent to 1 over 4 to the power of t, right? So these two are equivalent, they're written the same, and whenever you have a negative exponent, it kind of just flips whatever's in here, right? Now let's just compare what we get, right? So this is standard 4 to the t, and this is 1 over 4th to the t, right? And as you can see, the numbers are growing, right? So they're growing as they go forward, right? So it's obviously not the fraction, because if you go with the fraction, then you're going to go smaller and smaller and smaller. So the answer is D, right? So you kind of have to be able to use the knowledge of how graphs, different functions behave, both linear and exponential. And yeah, so that's pretty much it. So the next point that we're going to go over is understanding the bias and the inaccuracies of a model. A quality control researcher at an electronics company is testing the life of the company's batteries in a certain camera. The researcher selects 100 batteries, right? 100 batteries at random from the daily output of the batteries, right? And finds that the life of the batteries has a mean of 342 pictures with an associated margin of error of 18 pictures. Which of the following is the most appropriate conclusion based on these data, right? So first, let's kind of explain what mean and margin of error mean. So whenever you think of mean, just think of like an average number, right? So average number, and margin of error, right? This is kind of just how off or inaccurate the mean is. Mean can be, right? So it gives you a range of possibilities. So if let's, okay, so now let's kind of apply this to the question, right? There's another thing that we have to keep in mind, right? So let's go and look at A. All the batteries produced by the company that day have a life between 324 and 360 pictures, right? So we can't really say this is correct, because what this describes is, this is describing something called a range, right? We only know the average, right? And that the margin of error is 18 pictures, which mean, and the margin of error still describes the mean, right? So this mean could be off by 18 pictures, right? The average could be 18 more or 18 less, but every individual battery produced is not going to be within this range. There's something called outliers, right? And there's always going to be outliers. So this is just simply not true. Now let's go on to the next one. All the batteries ever produced by the company have a life between 324 and 360 pictures. So once again, this talks about the range, right? And on top of that, it's saying all the batteries ever produced, but what you have to keep in mind is the sample size, right? Sample size, or the population, right? We only tested the daily output, right? So we only know the mean, I should say, for that one single day. We don't know anything about the batteries that were produced yesterday or the day before that, or about the batteries that are going to be produced the next day, right? We only know about today. So this is wrong because it exceeds our sample size, our daily output, right? So now let's go into C. It is plausible that the mean life, right? So once again, we're going back into something that we actually know, of batteries produced by the company that day is between 324 and 360 pictures, right? So this is sounding more correct, right? Because the margin of error, once again, kind of says that the real mean of this is going to be 18 above or 18 less, and this kind of satisfies that. So now let's look at D. It is possible that the mean life of all the batteries ever produced. So alright, right there we already know that this is wrong, because once again the sample size is wrong, it's off, so we have C as an answer, right? So keep in mind the definitions of mean, margin of error, and how sample size kind of accounts for bias in problems. So we're going to do another problem that kind of asks about the same kind of question. A community center offers a Spanish course. This year, all students in the course were offered additional audio lessons they could take at home. The students who took these additional audio lessons did better in the course than students who didn't take the additional audio lessons. Right? Based on these results, which of the following is the most appropriate conclusion, right? So kind of pick an answer before we go over it. So once again, with these types of problems, right, asking about whether something is appropriate, we have to consider things like sample size, right? And we have to consider something called bias, right? So the situation is that they have an option to take these additional lessons, right? But and that the people who did choose this option did better, right? So now let's kind of go through the choices. So taking additional audio lessons will cause an improvement for any student, right? So we also have to remember that this is in a community center in a Spanish course, right? So for any student who takes any foreign language course, right? So we don't know how this will affect other courses. We just know how it affects the Spanish course. So that's why this is kind of unreasonable to say. So now let's go into the next one. Taking additional audio lessons will cause an improvement for any student who takes a Spanish course. So this one, at first, I kind of thought was alright, but I'll show you guys in a bit why this is actually not correct. Taking additional audio lessons was the cause of the improvement for the students at the community center who took the Spanish course. This also sounds okay, and no conclusion about cause and effect can be made regarding students at the community center who took the additional audio lessons at home and their performance in the Spanish course. So when I first saw this, I was kind of confused. Like, I never usually have 3 answer choices left. But what we have to take into account is the fact that these were additional, right? These were additional audio lessons. They weren't optional, right? So if you have a group of students, right, and they're taking all these resources, right, and they're reading all they can, and they're doing notes, and they're really studious, right, they're obviously they're more dedicated than somebody who didn't choose to take these additional audio lessons, right? So because of the fact that these students may be more dedicated and more academically, I guess, like talented, no, more academically adept, it could simply be because of the fact of this extra motivation that they have to take these additional audio lessons. So for that reason, we can't really say anything about this, surprisingly. And the answer is D, because if these audio lessons were forced and everybody was forced to take them, then you wouldn't have kind of a bias of who did better, because the people who did better could have just done better because of the fact that they're more motivated than the others. So this is one of the more complex ones, but yeah. So now we're going to tackle the next 2 points, knowing how to analyze a variety of different data plots and understanding measures of median, range, outliers, standard deviation, and mean. The histogram shown summarizes the distribution of time worked last week, in hours, by the 40 employees of a landscaping company. In the histogram, the first bar represents all workers who worked at least 10 hours but less than 20 hours. The second represents all workers who worked at least 20 hours but less than 30 hours, and so on. Which of the following could be the median and the mean amount of time worked for the 40 employees, right? So median and mean amount, right? and we also have 40 employees. So first, once again, let's go over what mean and median is. So mean, think of once again the average, right? And when it comes to the median, right, what you always want to think of is the middle number. So how would we find the average, right? So here you kind of have a choice to pick, right? You can kind of remember this is a possible average, right? Because once again, they could have worked any amount of hours in between these two, but because we know that this bar right here can be 10, but it can't be 20, we're just going to go with 10, right? So we know that 6 people worked for 10 hours, right? So what you want to have when you average is that you want to have like the number of hours divided by the number of employees, right? So this is going to mean 10 times 6, and you're basically going to write all of these out, multiplying them, the number of hours by the number of workers, in order to find how many total hours they got. Right, and whatever we get that, we're dividing it by 40, because that's the amount of workers. So if we put this into the calculator, you get 890, and 890 divided by 40 is 22.25, right, around there. So from that, you can kind of, the only one with this mean is B, right? So from there, you can kind of say that B is your answer, but let's go over what median is, right? The middle number, right? So if we have the middle number, right? So you have 40 people. So that means that, so the middle number is the middle of 40, right? So you would think that that's 20, but because this is an even number, there's not one single number that's in the middle. So what you have to do is that you have to take the average of the both most middle numbers, right? So that's 21 and 20. So if we look here, 21, right? So right here we have 6 plus something, right? So you know that the mean is going to be in this area, and because of the fact that you know it's going to be in the 20s, you can cross out D, right? But it's still in the range of this, because we can't know exactly the mean since they don't give us exact numbers. I mean, we can't know the exact median because they don't give us exact numbers, but we know it's in the 20 area because of the fact that the 21st and 20th person are within the 20 hours worked area. So the answer is B. The dot plots show the distributions of scores on a current events quiz for 2 classes of 24 students each. Which of the following statements about the standard deviations of the two distributions is true? So first, let's kind of go over what standard deviation is, right? So when I think of standard deviation, what I usually think of is I think of the spread of like data points. You also can kind of think of concentration, right? So if the data points are more centered in one area, right, then for example right here, this has a smaller standard deviation than this because of the fact that these kind of deviate towards this one point right here, while these are equally spread out. So this has a greater standard deviation because of the fact that it spreads out more, right? It has a lower concentration, but a greater standard deviation, right? Well, not really concentration. This is kind of iffy, but all right. So now let's use this in our questions. The standard deviation of quiz scores in class A is less than that of quiz scores in class B. So that seems true because as you can see here, it's more concentrated around this point. Therefore, the standard deviation is smaller. Alright, so now let's go to B. The standard deviation of quiz scores in class A is greater than that of quiz scores in class B. That is not true because as you can see, it's more centered around this. The standard deviation of quiz scores in class A is equal to that of quiz scores in class B. That is not true. The only way that these two would be equal is if it was talking about the range, right? Because it goes from 0 to 5 and here it goes from 0 to 5. And there's not enough information to compare the standard deviations. That is not true. So the answer is A. Phew, we got through a lot, but now we have one last point. The ability to calculate probability from a real-world situation. A store is deciding whether to install a new security system to prevent shoplifting. Based on store records, the security manager of the store estimates that 10,000 customers enter the store each week, 24 of whom will attempt to shoplift. Based on the data provided from other users of the security system, the manager estimates the results of the new security system in detecting shoplifters would be shown as in the table below. So, according to the manager's estimates, if the alarm sounds for a customer, what is the probability that the customer did not attempt to shoplift, right? So we're looking for when the alarm sounds, right? So right here, what I like to do is use a method like boxing in, right? So we look right here. So we're looking at for when the alarm sounds, and for when they did not shoplift, right? So did not attempt to shoplift, right? So this is the number that we have. So 35, right? Right. So now we need to see whether if it's over this or this, right? If the alarm sounds, right? So totally in a week, right? The alarm will sound 56 times, right? So that's kind of our whole. When you deal with probability, it's the same thing as fractions. It's just part over whole, right? So what is the chance that you got over the total number of chances? So yeah. Okay, so now all we have to do is put this part 35 over the whole of 56, right? And if we put that into a calculator, we get 0.625. So these questions can be one of the easier ones, right? So all you have to do is use this boxing method and learn and look at what they're referring to. So here they say when the alarm sounds, so you know that this is the total that you're looking for. If they said when a customer does not attempt to shoplift, then you would look at this. But they said when the alarm sounds. So this is our starting situation. So yeah, that's it. And we're finally done.
Congratulations on learning 29% of the entire math section. I know it was very grueling. For me, it was too, but we got through it. So, if you have any suggestions or anything about these videos, it'd really help because I'm really trying my hardest here to make it more engaging. And if you want more of the animations, I kind of only did one in this video because they take a lot of effort to produce. But if you think it adds to kind of your overall experience and understanding, just let me know in the comments and it would really be helpful. So yeah, thank you.